And that's what we discussed just now. Okay, right. So local field and internal field. Right. Next is Clacius Mossotti relation. Clacius Mossotti relation. Sir, why should we? Okay, what is Clacius Mossotti relation? Okay, this is your Clacius Mossotti relation. Okay, this is your Clacius Mossotti relation. Okay, so if this is Clacius Mossotti relation, why are we interested in it? Simple question. Why are we interested in it? It is just a relation between two terms and you did not do anything except for giving the relation. Then why are you troubling us with this derivation again? What is its importance? Okay. The Clacius-Mossotti relation is between alpha. What is alpha?
Polarizability.
Polarizability. It is atomic polarizability. It is atomic polarizability. That means this polarizability is associated with independent atoms. So that's a very, very, very minute scale, so it's a micro scale, okay, quantity. And you have to verify it for atoms. And whatever you do, okay, you should take a single atom and try to do and find out what is alpha. But that is not practically possible in ordinary senses. Okay, one thing. What is epsilon r? Okay, do you know that? Okay, this particular, okay, black box law relation rasan kada. Okay, do you know that? Okay, D is equal to epsilon naught E. What is E? External applied field. This is external applied field. Okay. But if at all, if you want to consider it in terms of a net field, then you actually multiply with another constant which you call as relative permittivity. Yama, relative
Permittivity.
right? So D is equal to epsilon naught into epsilon r into En, or which is equal to epsilon naught into E, where E is your applied electric field and En is the net electric field. Net electric field is nothing but the induced electric field and external electric field. But we also have a relation that D is equal to epsilon naught En plus P. Okay. So I'll use these two relations to say that P is equal to D minus E naught epsilon, epsilon naught En, and D is equal to epsilon naught En. So this is what I have. So, okay, I can say that P is equal to epsilon r minus 1 into epsilon naught into En. Okay, this is the expression for P in terms of En. This is the expression for P in terms of E net. Okay, now epsilon r minus 1 is represented by another symbol psi, where psi is called what? 5, 4, 3, 2, 1, 0. What is psi? 5.
Susceptibility.
Good. Answer is good. Answer is good. Who answered it?
Srija.
Yama Srija, what is psi?
Susceptibility.
Excellent. Good. Okay. Now, okay, Srija, you please don't answer. Others, what do you mean by susceptibility? I don't do. Okay, you don't have to use your physics for it. You have to just use your common sense and English. What do you mean by susceptibility?
So things which can be influenced.
Good. Okay. That means susceptibility is okay, the ability to get influenced. Okay, it is not okay ability of the external field, but it is a okay a material okay, which gets influenced. Okay, like for example, okay, during the COVID, who are most susceptible? 5.
Elderly people and
Elders and the kids.
Beautiful, beautiful, right? So susceptibility is associated with the people, not the COVID. Okay, no, not the virus. Virus will be acting okay, acting same on everybody, but some people are more susceptible and some people are less susceptible. Okay, that is what is susceptibility. Okay, some material easily get polarized and some material get polarized with difficulty. So to talk about the material's ability to get polarized, Apart from okay polarizability, we usually we usually take susceptibility in the bulk. That means the whole material is considered. So okay, when you talk about polarizability, you talk about independent atoms and molecules, and when you talk about susceptibility, you talk about what do you say, the whole material. Okay, so whole material is a macroscopic quantity. That implies this can be easily determined. How to determine this? Okay, that is psi is equal to epsilon r minus 1. How to determine epsilon r? Nothing. Okay, you take two okay parallel plates, find okay and find out the capacitance of it. Then between the parallel plates, okay, substitute a dielectric material. Then find out the capacitance. The ratio of these two capacitances gives you the dielectric constant. That dielectric constant is nothing but your epsilon r. The dielectric constant that you have used in your intermediate is nothing but your epsilon r. Okay, that is your epsilon r. Okay, so epsilon r can be easily be detected. That means can easily be measured in our laboratories with simple apparatus. But alpha the polarizability is associated with independent atoms, which is very difficult to measure in laboratories. That is why Clacius and Mossotti have developed a relation to determine the relation between the macroscopic quantity and the microscopic quantity. The macroscopic quantity is your epsilon r and the microscopic quantity is alpha. Okay, we are trying to determine this, and this is the derivation. Okay, I mean, if at all if you okay put in that terms, okay, you feel that it is very difficult and so. But if at all if you look at that equation, I'm just remanipulating everything again. Manipulation. Nothing is given. Okay, this is the only expression that you have to remember. This expression is the only expression that you have to remember. Okay, in this, what is it? P bar is equal to mu by V, that is dipole moment per unit volume. Now dipole moment I represent it as alpha into E. Okay, but where did this V go and where did this N come from? Okay, the question is where did the V go and where did this N come from? Okay, mu is equal to alpha E. Okay, but the problem is P is total dipole moment per unit volume. Total dipole moment per unit volume. Now what is this? If N is the dipole moments or say uh, dipoles per unit volume or atoms per unit volume or molecules per unit volume, then okay, this N talks about the total number of dipoles per unit volume into the dipole moment of each of that dipole. Alpha E is dipole moment of each of those dipoles. Alpha E is dipole moment of each of those dipoles. And N is the total number of dipoles present per unit volume of that material. So N into alpha E gives you total dipole moment per unit volume. Sir, in place of E, why did you take E local? Why did you take E local? Because when I am trying to find what is the net electric field here, this is not the external field, this is not the induced field, this is not okay ER or this is not this, but this is a combination of all the four. So what's because if I want to talk about what is the dipole moment produced inside this dipole, okay, independent atom or molecule, then I need to know what is the net electric field acting. The net electric field acting will be the E local field and not the induced field or the applied field. Okay, so mu is equal to N alpha E. Okay, mu by V is equal to N alpha E, where N is dipole moments per unit volume and alpha is the polarizability and E is the local field acting on that particular dipole. Good. After that, we have seen that P is equal to psi into epsilon naught into epsilon En, where psi is nothing but epsilon r minus 1. Okay, so this is the expression that you have here. Okay, P expressed in terms of alpha and P expressed in terms of psi. Good. Okay, so in place of E local, I'll substitute this expression. Okay, When I substitute this expression, E local is nothing but E net plus P bar by 3 epsilon naught. E net by, okay, that is what? Okay, En plus P by 3 epsilon naught. That's your E local. So I'll substitute it here. I did not do, but I just substituted. Okay, what did I do? Nothing. I just multiplied this term both sides. Okay, I got this expression here. Okay, in place of P, again I substituted psi epsilon naught En. In place of P, I substituted psi epsilon naught En. This is the expression. Okay. Now in this expression, I'm removing En. I'm removing En because En is constant. Okay, common in all of them. So I'll remove En. Nothing. Okay, I did not do anything. Okay, same. Okay, I removed this bracket, so I got this expression. Okay, and then I have taken this okay, psi epsilon terms to one side and an alpha to the other side. You got this expression. Okay, in place of psi epsilon r minus 1. Okay, and then okay, this is by 3 3. Okay, minus n alpha. Okay, so I take it this side. We got n alpha by 3 epsilon naught is equal to epsilon r minus 1 by epsilon r plus 2. This is your Clacius Mossotti relation. This is your Clacius Mossotti relation. Okay. Why is it important? Because it is trying to get a relation between a atomic quantity and a macroscopic material quantity, atomic quantity and material quantity, or